Hello. In this video, I'm going to walk through my Calgary traffic incidents, cameras, and signals web map for ENGO 451 Lab 4. I'll show how the Flask app talks to my PostGIS database, how I fixed a really annoying bug with the traffic incidents table, and how the three layers named traffic incidents, traffic cameras, and traffic signals get turned into points on the leaflet map. So first, here's the database I'm using. The database name is ENGO451 and the user is Postgres, and inside it I'm using the lab4 schema. Under that schema, I have three main spatial tables named traffic incidents, traffic cameras, and traffic signals. Each of these tables has a geometry column and an ID column that I use as a primary key when I send the data to the map. Now I'll switch over to the VS Code and show the Flask app. At the top of the app.python, I import the first four lines. And then, I write the first four lines of the code. And then I create the Flask app and configure the database connection. So this line connects Flask to the ENGO 451 database on port 5432 using SQL Alchemy. The debug block because I experienced problems finding the traffic incidents table and caused me a lot of frustration. I created a debug code to basically help me find out the problem because it wouldn't identify or it wasn't able to find the traffic incidents dataset from the schema. Because of newer versions of Flask and SQL Alchemy, I need to run the database code inside an application context. So I wrap the code and I run a couple of debug queries using text. First, I check which database and the user I'm actually connected to, and then I list all the tables in the lab4 schema, which was really important because at first Flask giving me the error that code relation lab4 traffic incidents does not exist. I thought the table was correct, but when I printed out the lab4 tables from this debug code, it just wouldn't show up. The problem with it was that the table name in the database actually had a trailing space. So it had a space after the word traffic incidents instead of only traffic incidents. Because of that hidden space, my SQL queries in Flask couldn't find the table. Once I was able to see the real names from the debug output, I fixed the table name and made sure my queries used the exact same spelling as the database. After that, the error disappeared and the map started showing. So onto the index and map data functions. Flask only has two main routes: the homepage route, which serves as the HTML page, and the other route where all of the actual map data comes from. I define a list of the three table names I want to display. From each table, I build a SQL query that would transform the geometry from its original SRID to WGS84 and converts it to GeoJSON and returns the ID as well. Then I execute it with the SQL Alchemy, and for each row I parse the geom_JSON string into a Python dictionary and build a GeoJSON feature. All these features are stored under the code layers brackets table. At the end, I wrap each layer in a feature collection and return everything as JSON. So when the front end calls my map data, it gets an object like this. In index.html, I set up the leaflet map. First, I include the leaflet CSS and the JS, then I create a full screen. Then I fetch the GeoJSON from the map data. For each layer, I create a leaflet l.geojson and use the custom icons such as a car icon for the traffic incidents, a camera icon for the traffic cameras, and a signal icon for the traffic signals. To make sure the cameras draw on top so that it's easier for it to be visible, because there are quite less data set for the cameras as compared to the traffic signals and the traffic incidents. I had layers in order and use a higher z index for the camera layer. Finally, I add a layer control so I can toggle each layer on and off. The reason for me using the custom icons in the code was that since the dataset is so huge, my browser kept crashing and kept loading because it wouldn't load the like the data set for the huge data set for the traffic incidents and the traffic signals. So I just found I used the icons as a get around so it would load faster, and it worked because then it was finally like the map was finally loading. And then I did a quick data check with Jupyter. I create a small Jupyter notebook to double check the row counts, for example, this. And then which confirmed me that the number of traffic incidents has 50,163 rows, traffic cameras 186, and the traffic signals 1,702, which basically matches what I see on the map. So to summarize, I connected Flask to my local Postgres database using SQL Alchemy. I added a debug block to print the current database, user, and the tables in the lab for schema. That debug code helped me find a hidden space after the traffic incidents table name, which is why the table wasn't being found at first and it kept showing errors. Once that was fixed, I built the map data route to query all three spatial tables, convert them to GeoJSON, and send them to the front end. Finally, I used Leaflet to display traffic incidents, traffic cameras, and traffic signals with different icons and layer control on top of an OpenStreet base map. And that's pretty much everything. Thank you.